regulators. We regulate any stealing of his property. We're damn good, too. But you can't be any geek off the street. Gotta be handy with the steel, if you know what I mean. Earn your keep.
Regulators! Mount up!
Oh, timing that is so hard, right? Hey, JSConf Australia! Yes! Thank you very much. Hello. I am Ruth. That was it, I'm done. Thanks. No, I'm joking. Oh, no, I like that intro. Normally at the top of a talk, people would introduce themselves, sort of say what job they do, what sort of credentials they have, what they do day to day. I kind of think it's probably easier if I just show you. So that's what I'm going to do. So I'm here today to talk to you about being a web AV artist. I know, right? What? Like, what even is that? To be honest with you, I kind of struggled with the practicality of this talk. I was sort of sitting at home and I was like, they're gonna listen to some crazy stuff, and they're gonna go back to their jobs, and they're gonna be building websites and web apps and progressive web apps and web things and all the things that they do. They're not really gonna be doing audio visuals. They're not gonna go back to their jobs and be like, hang on a minute, I'm just gonna put some AV in this website. It's gonna be super cool. Did anybody see this Venn diagram that's going around the internet recently? The Practical Dev tweeted this. I just realized I've forgotten my coffee, one sec. Have a little read of this Venn diagram. Coffee's important. Thanks. So on the right there, we've got like what is in conference talks, right? And on the left is what is useful to be in conference talks. And as you can see, there's no overlap. So I was thinking to myself, what I could do was make two lists based on the diagram. So this is, on the left, these are things to avoid. So these are things that happen in conference talks, which if I can avoid in this talk, it'll be useful, because I can include all the stuff on the right. So that's all the stuff that will be useful to you as developers, right? So avoid analytics, operational excellence, chat ops, orchestration. I think I can avoid that stuff. That's great. But I do have to include duct tape, workarounds, bike shedding, coffee. Right, cool. Okay. So now we've got the talk anxiety bit out of the way, and I know what I'm going to have to include and what not to include. We can begin. What is a web AV artist? So AV stands for audio-visual, right? So audio-visual artist is somebody who sort of puts visuals or creates visuals based on audio. So it's a little bit more towards the visual end rather than the audio end, even though we do work with a little bit of audio. Another word for this is VJ. Does anybody in the audience remember this?
Winamp. It really whips the llama's ass.
Yeah, cool. People are putting their hand up. That's so brilliant. But any of you that don't remember, I can see some young faces around. In fact, I thought most of you were, actually. This was the MP3 player of choice back in the day, when we actually used to hold like audio files as hard files and didn't stream them. It's a really, really lovely, lightweight sound player, which is why we chose it. It literally just does play sound files. But this wasn't the best thing about Winamp. The best thing about Winamp was this. It had a visualization engine. So you'd play your music, and you'd fire up this engine, and it would show you all these amazing visuals that went in time to the music. This was probably the most influential thing of any VJ of my generation. We probably just used to sit there going, oh, wow, wouldn't it be cool if we could make this? This is amazing. Like, it's just visuals going in time with the music. This is great. So I'm going to take you through the techniques that I have used to kind of try and recreate the idea behind this within a browser. So the first thing that we need is audio, right? And we've got this with the Web Audio API. Now there's 4 main ways to get audio with the Web Audio API. We can create a sound, so we can create an oscillator, which is essentially creating a sound wave. And that's a way to create sound. We can add sort of effects afterwards, and we can change volumes and panic and all this other lovely stuff we get the audio API. But that's the first way. We can grab it from the DOM. So we can get it from an audio or a video element, and we can pipe that into the audio API. We can stream it from a media stream source. We saw this with Soledad earlier. We can just pipe it in from our camera or a microphone, and we could stream it into the audio API. Or we can actually buffer it from a file. So we can load a sound file into the audio API via a buffer. The latter two are probably, or the latter three are probably the ones that we kind of want to look at for when we want to analyze, which is the next bit. So 2 ways.
Regulators.
Any excuse
Regulate
to play
any
this.
stealing of his property. We're damn good, too. But you can't be any geek off the street. Gotta be handy with the steel, if you know what I mean. Earn your keep.
Regulators! Mount up!
Oh, great. So that first way, I was loading in a sound file, and I was analyzing that sound file. This second way is picking up on my mic. So it's actually analyzing the sounds of my voice going. And that's the next bit that we need. Once we've got sound, so that was almost the easy bit, the next bit we need to do is analyze it, right? I'm not allowed to talk about analytics. So I kind of failed on the first one already, but it's fine. We've got like 3 more. I can totally get this talk done without actually getting all this wrong. It'll be amazing. So yeah, we need to analyze sound. This is probably the most important thing of the stuff that we're actually going to do. And we can do that with the Web Audio API as well. So there's an analyzer node. If you don't know much about the Web Audio API, it all works within nodes. You have like input nodes, you have modification nodes, you have output nodes. So the input nodes were what we were talking about earlier with like loading sounds in. Modification nodes are things like the analyzer node, you've got volume changes, you've got filters, there's lots of things you can do with that sound. And then there's output nodes, which for the majority of the time is your speaker. And you kind of string all these nodes together, and that's how you kind of use the audio API. So the analyzer node gives us frequencies, and it analyzes frequencies. So frequencies are like tones, so it's like low to sort of high. And it goes from 0 hertz to 20,000 hertz. So that's the range that the human ear hears. You might not hear 20,000 hertz when you get a little bit older. I know that I probably can't hear 20,000 hertz. And actually, music doesn't really go up that high, so you'll be fine. But that's what the analyzer node gives us back. And it gives us back to us in an array. So we create an array, we give it to the analyzer node, and then that gives us back the volumes of each of the frequencies that we can make that array whatever size. And the bigger that we make the array, the better resolution of analyzing that we get. So it's pretty simple to make something like that once you've got all that information. This is just a bunch of I elements sitting in the DOM. And all I'm doing is looping over that array and looping over the I elements and attaching one part of the array to each one of the I elements. And as the sort of velocity or the volume of each frequency is going up, as is the height of each of the I elements. It's pretty simple. That's it. But this is kind of quite powerful stuff because we're using the DOM, and the DOM's pretty cool. So I sort of started playing around just with this simple idea to start with, and we can add more stuff later. This is a pretty cool artist. See, super cool artist. It says it on the slide, so she has to be. Her name's BRIDGET Riley. I discovered her in Scotland earlier this year. And she does these like huge, big paintings, which are quite simple in effect when you look at them. They're sort of like, you can see them here. They're just kind of lines. But the way that she does it means that there's sort of movement through these lines. And when I saw them, I was like, oh, I kind of want to make those into visuals. So I kind of did that. This one's cool. This is just checkers sort of, again, it's just DOM elements. So we're just changing the width of those DOM elements based on like the sound. And I'm still doing that thing where I'm picking up on my mic. So this is picking up on the sounds that I'm getting and analyzing it and then changing the widths, like dependent on what frequencies that I'm passing it in. We can expand on that, so triangles, fadey triangles, and then bright triangles, and then fadey. But like, because we're using a browser and we're using the DOM, there's some other like great things that we have with that. There's some great, lovely CSS things, which is a great thing to talk about at a JavaScript conference. Transforms. So I thought it would be really nice if I could grab whatever was in the DOM and reflect that and rotate it around, and we could do some like symmetry, which would be great for like end visuals. So I did do that. So this again, it sort of flashes in time with the music. So if I go quiet, it kind of disappears, and then when I go loud again, it comes up. But it's just transforming. It's just grabbing. There's a function. It just grabs whatever's in the DOM and then reflects and rotates it around. After I built this, I thought, wonder if I could put a GIF in this. Yeah, we could do that. Cartoons, man. Always do cartoons with your viz. So this is just exactly the same code, and we're just dumping a GIF in, and it's just rotating and reflecting it around. Browsers are so good for this sort of thing. Other things that we get with CSS now are things like blends and filters, which are really nice. So this is very suited to what we do, and the opening that I started with earlier with these pictures of the speakers, these are using both blend modes and filters. So if you aren't aware, blends are sort of a transparency layer over your elements. If anybody has used Photoshop and used layer modes, you'll be very, very familiar with them. If you haven't, it just sort of adds a nice sort of veneer over like your foreground and your background. So you've got like mixed blend mode as a property, which you can put on your element. There's also background blend mode. If you've got sort of background images, you can use them in that way as well. There's also filters. So the pictures of the speakers actually do use a sort of contrast filter, which is picking up on the analyzing and making it stronger and weaker as it goes. But the filters are very good for things like images, especially good for video. You've got things like grayscale, inverting, blurring, like all this kind of stuff, which is it's really good when you want to put that in time with the music. I was talking about CSS, and I'm going to carry on, but wait for it. It gets more interesting. Custom properties. Right, so we have custom properties in CSS now. So this is sort of like variables. They're not quite exactly the same, but they are. You declare them at the top of your CSS file, and then you can use them throughout your CSS, much like you would with a preprocessor. I'm sure we're all familiar with it. So something like this uses a lot of the stuff which I just described. So it's just sections with I elements in, and then I've rounded them off, and then I've rotated them around. But the width and the height of them is changing, like dependent on a custom property that I've set. But I'm changing the custom property with JavaScript, and that's going directly into my CSS. This is kind of fun. This is JavaScript all up in your CSS, right? So this top bit is the CSS, so we're declaring this variable like -- level, and then at the bottom here, this document.element.style_set property, I'm actually passing in one of the frequency velocities. So when that gets louder or softer, it's actually changing the level and actually changing my CSS directly. I like someone's doing this at the back. I'm like, thank you very much. So that's really, really interesting. Now, there's one thing to note about this technique, and I don't know whether you realized, this is actually a GIF, because to put it within my slides and to actually have it running is really, really hard because it's not very performant. What? I'm not allowed to talk about performance? Oh, operational excellence. Not allowed to talk about performance. Okay, 50% down. It's okay, we'll still be all right. Custom properties, when you're using them with sort of widths and heights and you're constantly polling them, they're not very performant. I found this out the hard way. And I was talking about this with my friend, when I was chatting to my friend. Not allowed to talk about chat ops either. Yeah. I've got one more to go. I'm not allowed to talk about orchestration. I think I can get away with this. I think I can end the talk with just orchestration left. I think we'll be all right. Anyway, this is Ben. This is my friend Ben. And I was talking to him about performance because I sort of did this interactive installation at JSConf Brazil, and there were 1,500 attendees, which is a lot of people to do something interactive with. It didn't really work. Chrome doesn't like 1,500 people connecting to it. So he kind of helped me out, and he went through my code when I got home. And he was doing some really, really cool stuff with D3 at the time. We had a talk from Nadia yesterday about D3, so it was really, really interesting to see his take on it. And it's really good to talk to your friends about stuff and show them your code, because then they introduce you to other things, and then your whole world kind of expands, which is cool. D3, he kind of introduced me to this idea that it might be better for some of my visuals as far as performance goes. So D3 is really, really good at data. I'm using a lot of data. I'm doing a lot of analyzing of frequencies. It's basically data. It's also really good with DOM stuff. So we use it for a lot of SVGs, which is on the list here. But actually, it's quite good just working with the DOM and making that performant. Also really good at maths. Super important if you're working with data. It does have a lot of sort of manipulating sort of methods and functions. So it was really, really interesting to start using it. This was my inspiration for my D3 set. This is a book called Super Graphic. It's all to do with, it sort of takes data from comics and graphics novels and sort of puts them in it's just a lovely book to flick through. It's just data visualizations from comics and graphics novels. It's really cool. But it's really interesting because it becomes really, really easy to sort of make things like this. They look really good when you've got a lot of bass. But this is just a really simple D3 example, and you're just moving it around just based on the frequencies. And then you do accidental animation, which is actually a thing. So this is one that went wrong, but actually it looks really nice. So I was super happy with that. And then this one's kind of a bit crazy. I kind of have to be a bit quiet. This one's dots. Yeah, it's really, I'm wondering whether my radius math is a little bit out. But as Nadie showed me yesterday, you can put, woo. Oh, really quiet. You can put blend modes on it. That was so cool. I'm so glad she showed me that. I was like, yeah! And it makes it go white when it's really loud. I can change the volume of the microphone. It's cool. And then we just have simple ones. Yeah, I quite like that. It'll be a really nice overlay for a video, I think. I wanted to talk just very, very briefly about the analysis that we're doing on the audio. This is probably the most boring part of the talk. We are creating a linear array of values from 0 hertz to 20,000 hertz. And most music will not go up to 20,000 hertz. It probably wouldn't even go up to 5,000 hertz. Plus, we have a linear array. So we kind of need to do some maths on that analysis. We need to break that array down. We can probably take the first quarter of those numbers, and we also need to spread it out. It's a linear array. Music is not linear. Music is logarithmical scale, right? If you actually play a piano and you go from one octave to the next octave, for people that aren't musical, that means sort of you're going from like the same space to the next space to the next space. You're actually doubling frequencies. You're not going up like 1, 2, 3, you're actually doubling. That makes it a logarithmical scale. Now, I've only just started thinking about this. So I'm going to be doing some work around the maths and hopefully making them a lot easier to use for the analysis, which could hopefully mean that things like beat detection, low frequency, mid frequency, and high frequency detection within the actual sort of software and sort of visual ways could be a lot easier. I sort of did some pseudo stuff on this one, and you can see it's spread out a lot more. So I've kind of broken this array down. If we jump back up to this one hasn't, and you can see how it's kind of bottom heavy. Almost. So the red on the bottom there's a lot more activity in that end of the array, which is fine for visuals, I think, in the short term, but I think if we actually want to do some proper analysis, and like I said, beat detection, we're going to have to sort of think about that a little bit harder. This is only just something I was thinking about in the past couple of days. Oh, cool. We got visuals. If you want to see more of these, I did Codevember this month, and there's a big collection of them on CodePen. Including some of the ones you just saw then. So it's kind of easy to create visuals, right? We can all agree that was fun. We've got some analysis. We made some trivial cool stuff to it. But we kind of want to control them as well. And we've got a keyboard connected to our laptop, but that's not really exciting. There's a Web MIDI API. That's more exciting. So I'm going to do a quick background in MIDI so we all are aware, because I'm sure there are some people in the audience that don't quite know what MIDI is. MIDI is not 80s bleepy music. MIDI is a data protocol that came around in the 80s because there was a rise of electronic instruments in the 70s. And so industry experts and music manufacturers got together and they said, wouldn't it be really, really nice if all these instruments could talk to each other? Because they're all electric. You would think that actually we could find a protocol where they could all talk to each other. And not just to each other, but go into recording studios and talk to recording equipment as well. And that's how MIDI came around. The first spec was General MIDI 1. It's kind of moved on now. We have General MIDI 2. There's a lot of other specifications as well. But for the most part, that's what MIDI is. It's just passing numbers back and forth between equipment. And this is the crux of the Web MIDI API as well. If you plug a MIDI instrument or controller into your computer, you are just essentially, if you run the code, getting numbers, which makes it quite powerful if you want to hardware enable your browser. I would recommend playing with it if you want to. One thing to bear in mind is this is a MIDI instrument. Orchestration for instruments. Fine, okay. This is literally like the most useless talk ever right now, but okay, we'll go with that. This is a MIDI instrument. Okay, MIDI instruments have onboard audio. I'm sure you've all seen one of these. This is a keyboard, you play it, plays music. It probably has, these days, probably has a USB port. So you can plug it into your computer, and if you run code in the browser, you can actually feed back MIDI information into your browser for a normal musical keyboard. That's cool. The difference between that and something like this, which is a launch pad, is this is a controller. There's no onboard audio, right? For the most part, these are slightly cheaper than instruments. You can actually pick up keyboards pretty cheap these days, but for the most part, these are just boxes. This is my handbag MIDI controller. I didn't put it too far away from my computer because it's Bluetooth, so it might lose connection. This is a Bluetooth-enabled one, so there's no USB connection, but it should be still connected to my browser, fingers crossed. And it's just buttons. There's a nice little crossfader on here. So I can kind of use it with my visuals, please let this work, to kind of crossfade, there we go, from one visual into the next visual. I'm hoping we can kind of all see this at the back. So all I'm doing is just polling these values. This is a CC controller, and it's just passing me numbers. And when it gets to one side, we're showing one visual. When it gets to the other side, we're showing another visual. And then we can kind of stop it in the middle and kind of show both. Which is super handy if you want to mix visuals live, right? There's some nice effects on the buttons as well, so we can like flash invert and things like that. You can set these buttons up to do whatever you want. For the most part, I generally set them up so I have different sets, so I load different things into the divs, I have some effects, and then I can crossfade between them. Super handy bit of kit to have, and it fits in your handbag. Whew. So that's how we control the visuals, great. But is this at all real? This is such a hobby talk, right? This is me. I have a pocket projector. So I created like an usherette tray bag that opened up with my laptop and my MIDI controller in, and the projector projects out from the bottom. And this is me projecting onto the streets of my city last year. We did it at Christmas. It's cool. I'm just playing music, just walking around the streets, just projecting. I love the fact that you guys are laughing. There's an article about this on 24 Ways, if you're interested in it. It's like how I made it. But really, though, I started a collective called Live.js. So this is all different people doing live things built with JavaScript. Matt is here today. He's doing some stuff tonight with some stuff he built that does live music. I'll let him talk to you about it. Tim does some stuff with LEDs, which is amazing. Martin controls lights with JavaScript. It's great. Like, they all do their own thing, and it's amazing. Last week we were at JSConf Asia. I think Thomas is here in the audience. Yeah, there he is. He's waving. He organized. He invited us to do it. We did a gig. We're doing gigs. I know. You think this is a hobby? No. We'll be doing some stuff tonight as well, so hang around. This is how real it is. We have a GitHub organization. Defo real, right? When you've got a GitHub organization, think, shit, it's getting real. I am actually coding my own software based on all the things you just saw. So the analyzing music and making that better, controlling it with MIDI and being able to hook up different MIDI controllers to it, including things like video. There's a lot of video in my sets these days, as well as all the animation stuff which you just saw in the talk. I have like two versions. I have a really, really hacky version, which I have been just using as a sketchpad for the past sort of 18 months, which is on my GitHub if you want to look at the code, but I wouldn't. It's not nice. I'm rebuilding the software, and it'll be on this organization if you want to see it. I'm not going to show you a demo within this talk, because Matt is doing some stuff later tonight, and I will be doing projections for it for the after party. So if you want to come up and see and chat to me, I will be here. There will be projections on this projector. It will be amazing. There's one last thing I would like to address. Most useless talk ever so far, right? But for the keen-eyed among you, duct tape. Not actually holding the bag up. The harness really works. There's duct tape sellotaping the laptop to the bag. Ben's on a bike. Yes. There's a workaround in this. Oh, didn't I get a down for that? Damn it. There's a workaround in this code. I tried to do maths in a CSS. Don't do maths in CSS. I know we have calc now. It doesn't work. Keep your maths in JavaScript. It is much better for it, even with floating shit, honestly. And also, I got coffee. Most useful talk ever. Thank you very much. I have been Ruth John.